Hi, am I audible? Hello, am I audible?
Yes, sir.
Yes, sir.
Okay, okay. Hi, welcome to the first live session of this Algebra 1 course. First, let me introduce myself. My name is Shavik. Right now, I am doing my research at IIT Madras under Dr. Ramesh Kaushik. Okay, and my this Algebra 1 live session will be done twice twice in a week. Okay, each session will be around 2 hours. The the modus operandi of this live session is to clear some doubts of yours, and also you can ask some doubt or some concept which you are going to issues. Okay, and then we shall go with some problems. First we go some easy problems, then we if possible and if time permit, then we'll go with some difficult problems. Okay, so okay, so first let me know how I mean is everybody are from maths background, or how many of you are from other backgrounds? Let me know. How many of you are from other backgrounds? Okay, you're pharmacy. Okay, so Darva Sastri. Okay, so okay, so Sastri, Darva. Yeah, so Darva. Yeah, so um, so have you studied group theory before, or the permutation group, or conjugation, etc.? Have you studied before, or this is your first time you are doing it? Okay, you have some idea. That's good. Okay, so can you please tell idea means which portions, or can you specify some topics in order to understand it? Can you some specific topics up to which you know something like that? Yeah, Darva, can you please specify up to which portion? Okay, basics. Okay, okay. So in basics, you mean you have some basic idea of Lagrange's theorem, then mm, this permutation group, and then normal subgroup, etc. You have some this type of idea, right? Okay, you student. Okay, okay, okay. So Tejasri, okay, you just student. That's okay. So have you studied basic group theories, normal subgroup conjugation, etc. till now? Okay, okay. So yeah, Tejasri. So how much? Yes, that's okay. I mean, studying means which portion you are studying. Like, I mean, specify some topic or some portions. Just to specify some, okay, basic test. Okay, okay, I understand some axioms. Okay. Uh, okay, so by axioms you means the in the axioms that appears in the definition of a group, or you have already studied subgroups, those things, or you have just studied the definition of group. Okay, okay, I understand. Okay, okay, thank you, thank you. And okay, so what about others? I mean, those. I mean, there are many students. I guess. Yeah, there are 40. Okay, you have studied subgroups. Okay, I understand. So there are 13 students, others. So other 10. So what about other 10 students? Are all of you from math background, or you are from another background, or till now, what is your position in the algebra? What about others? Okay, so mathematics background, maths background. Okay, okay, that's good. So, how many of you are from PG, or everybody is from UG? I mean, those who are from PG can raise your hand. Okay, got it. Okay, okay, most of them. Also, I just want to know, I mean, is there anyone who is just taking the course, also doing some kind of job, or also doing PhD but taking this course also? Is there anyone? Okay, okay, okay. Your PhD biotech. Yes. Okay, so okay, many of you are from PhD, but other some of you are from other backgrounds also. Okay, so as far I know that Sir has done the permutation group. So just I want to get you one second. Okay, so I want to know which one is better. That should I first recall the definition, some properties of permutation group, or should I directly start with some problem solving? I mean, it's your choice. I mean, this class is for yours. So you suggest in accordingly we can go. Okay, it would be nice. Bharba says so. I mean, it would be nice in which way? Can you please specify? Okay, okay, done. Okay, sure, sure, sure. So okay, so just I want to be clear one thing. So yeah, since some of you are some other background, so should I start from a permutation group, or should I start from basic group theory definition axioms? Because some of you just studied or just studying the group subgroup etc. So please let me know, should I start from the basic group definition, or should I start from the permutation group? What about others? Okay, okay, sure, sure. Okay, so today we are going to start with uh, basics from permutation group. Okay, but in between, since some of you are studied or studying the definition of groups, subgroups, etc. So if you have any issue in with the definition, because I am assuming the definition of groups and subgroups of course, but in between, if you have any issue, please ask me. Okay, so let's start. Yeah. Are you able to see the screen? Okay, sure. So, okay, so before going to the definition of permutation group formally, first let's try to understand in an informal way what it does represent. Okay, I mean, what does it mean by permutation group? Okay, so suppose consider this set I3. I don't know whether you are familiar with this notation I3 or not, but I3 means 1, 2, 3. Okay, these three elements mean the set I3. Okay, so consider the set I3. Okay, now in this set I3, consider all possible bijections. So, okay, so in this set I3, what are the all possible bijections? Can anyone please unmute yourself and please tell? Fixed bijection. That's good. Okay. So, okay, so I'm not writing all the bijection. I mean, so sigma 1 will be a map from I3 to I3. So, for example, there will be one bijection, 1 goes to 1, 2 goes to 3, and 3 goes to 2. So there will be something 3 factorial number of bijections, total 6 bijection. Okay. So now the point is that this all possible bijections forms a group. That is the main motto of this permutation group. Okay. So in order to make this in the group, first we need to check that whether the first we need to define the group operation, right? So what is the group operation here? Right. So so the group is consist of all possible bijections from a set I3 to itself. So what is the obvious group operation? The composition operation. Okay, this is a composition operation, and so this is the group operation. And so we need to check in order to maybe in order to be group. First, we need to check the whether the associativity has been satisfied or not, right? Now the point is that since it's a function, so in function associativity law has to be satisfied, right? And secondly, we need to define the identity. What will be the identity map? So if we choose this bijection where 1 is going to 1, 2 is going to 2, 3 is going to 3, then and if we define this map by small e, then it is easy to observe that sigma 1 composed small e. If you take any bijection sigma and if composed with this map e, then you will get sigma itself and this vice versa. Okay, so this is the identity. And what about inverse? So if we take some small sigma, we need to find sub gamma such that gamma compose sigma is equal to sigma compose gamma is equal to that e identity, right? We need to do something like that. So for example, sigma is something like 1 goes to 2, 2 goes to 3, 3 goes to 1. So if we choose gamma such that these two, sigma will be, so basically this gives what? This will be gamma is nothing but the sigma inverse, right? So it sends 2 goes to 1, the 2 goes to 1, 3 goes to 2, and 1 goes to 3. Sorry, it's my mistake. It should be 3 goes to 2. So this is sigma inverse, right? Yeah. So under this operation composition, associativity is satisfied, and also we have the identity and the inverse property has been satisfied. So this all possible collection of bijections forms a group under this composition operation. Okay, so this is what we mean by the permutation group. Of course, I mean, we have started with this set I3, but in general, we can start with the set IN, where this IN means 1, 2, dot, 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 n. Okay? So that's the definition permutation group. So anybody, any questions still now in the definition of this? Any small question, any small doubt, anything? Yeah, yeah. I3, Tejasri, sorry, Tejasri, actually the chat screen was beside the OneNote. That's why I could not say. Yeah, I3 to I3 itself, right? Bijection on I3 means I3 to I3 itself, right? Okay, so does anybody have any doubt or any confusions? Please let me know.
Sir, in proving the associativity, sir, we have taken to it to be granted. Sir, if the number n is greater, do we have to check by examples, or is there any general way to prove
The
this
thing is,
associativity property?
the thing is, uh, the operation of the operation is the just composition operation, right? Now, in case of if you take any three functions, then the absolutity obviously holds, right? I mean, forget about this I3, forget about the bijection. If you take any function f, g, h, where this absolutity makes sense, then you will definitely have this, right? This is always correct, right? Are you there?
Okay, sir.
So absolutity is actually by default true. Yeah. So anybody have any other questions in this up to this portion? Okay. So one second. Hmm. Okay. So this is the definition of permutation group. Now come to the one. Now come to the convention. How to write in practically in several. Okay. So first we start with IN. IN is the set of all first n natural numbers. Okay, and then consider all possible bijections. I3, I3 itself. Okay, and then with the group operation as composition. Sorry for the bad handwriting. If you have any issue in understanding the some portions, please ask me. Okay, with the group operation composition. So, and this group is known as the permutation group of n elements. and it's denoted by Sn. Okay. By Sn we mean the by so permutation by Sn we mean the permutation group of n elements. Okay. Yeah. So now suppose alpha is an element of Sn. This means what? Anybody? Suppose we have taken an element alpha from Sn. This means what? Anybody?
It's a bijective function.
Okay. Yeah. By function. Okay. Yeah. From In to In, right? Hmm. Sorry, In to In. So it's a bijection of In to In. Okay. But in reality, we don't use this notation in case of problem solving. So in there, I mean, from now onwards, alpha is an element of Sn by mean. I mean, we write this in this way. Suppose 1 goes to alpha 1, I mean, 1 goes to alpha 1, 2 goes to alpha 2, and dot 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 n goes to alpha n. Okay. We write this thing as alpha equal to 1, 2, dot 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 n, alpha 1, alpha 2, alpha n. Okay. We write this in this way, and this is an element of Sn. This is the convention. Okay. Okay, this is the convention. So under this convention, uh, suppose beta is another element, 1 beta 1, 2 beta 2, n beta n. Okay. So so one thing is that, so what will be alpha composed beta? Alpha composed beta. One second. Yeah. Okay. What will be alpha composed beta? So alpha is a map from In to In, and beta is again a map from In to In, right? So yeah. Yeah, okay. So alpha is a map from I to N, beta is the map from I to N. So what will be the map alpha compose beta? Under alpha, 1 goes to alpha 1, and then it goes to beta of alpha 1, right? Okay. Similarly, 1 goes to alpha 2 and goes to beta of alpha 2, right? And dot 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 1 goes to beta alpha. So this is beta compose alpha. Okay. So for example, uh, suppose alpha, beta are element of S6, and suppose alpha is equal to 1 1, 2 3, 3 4, 4 6, 5 2, 6 5, and suppose beta is equal to 1 6, 2 5, 3 3, 4 1, 5 2, 6 4. Okay. So this is alpha, this is beta. Okay. So can anybody please tell what will be alpha compose beta? You can take your time, no issue. Does anybody tell what will be alpha compose beta? You can take your time. Anybody please?
Excuse me, sir.
Yeah, yeah. Yeah, sorry. Can you please repeat?
Yeah, may I tell the answer?
Yes, sure.
So 1 goes to 6, uh, 2 goes to 3, 3 goes to 1, 4 goes to 4, 5 goes to 5, and 6 goes to 2. And 5 goes to 5 as well.
How 5 goes to 5? Alpha and beta are both bijection, right? So composition will be also bijection, right? So you have already told that 2 goes to 5, right? So how
Sir, 2
5?
goes to 3. Sorry, sir. 2 goes to 3.
Okay, 2 goes to 3 and 5 goes to 5. Yeah. Possibly, no. You have done the beta compose alpha instead of alpha compose beta, because when you are doing alpha compose beta, first beta comes, then alpha comes, right? So you need to do this in the following way. So you should take 1, then you are looking at 1 goes to 6, and then in alpha you need to look where 6 goes. 6 goes to 5. So in alpha compose beta, 1 goes to 5. 2 goes to where?
2 goes to 2.
2 goes to 5, 5 goes to 2. Yeah, 2 goes to 2. 3 goes to 4,
4.
and 4 goes to
4 goes to 1.
5 goes to 3,
6,
and 6
3.
goes to
3.
6. Yeah.
3 goes to 6.
So that's the so the thing is, you need to remember the order of the composition. Okay, which portion is at the end, first you need to start with that, and then you need to come in the reverse direction. Okay, that's the technique of doing the composition. Okay, I mean you can do the composition in the usual manner, but the thing is that you have to write alpha and beta explicitly. Okay, so when we don't want to do this, that's why this is the technique of doing calculating the composition one I mean usually. Okay, so yeah, so another basic thing is that, so let's calculate, I mean, some inverse. Suppose alpha is an element of S3, and then suppose alpha is equal to, then what is alpha inverse? So remember, alpha inverse is something such that alpha compose alpha inverse, and alpha inverse compose alpha give the identity, that is this map 1 2 3 1 2 3. Alpha inverse is something like that. So what is alpha inverse? Can anybody please tell? I mean, you can do the calculation in explicit way. Suppose, I mean, you can write alpha as function alpha 2 is equal to 1, alpha 3 is equal to 2, alpha 1 is equal to 3. Then you can calculate the inverse. But finally, put the alpha inverse in this form and please tell the answer. How, I mean, please tell the answer then. Okay, take your time. Still answer? Anybody?
Sir, 1 goes to 2. Hello.
Yeah. 1 goes to 2.
No, 1 goes to 2, 2 goes to 3,
Yes.
and
And
3 goes to 1.
yes, okay. So just I want to know how you have calculated. I mean, like you have written explicitly alpha, there you have calculated alpha inverse, right?
Yes.
Okay. Uh, Anybody, any other? I mean, is there anyone who has done this in different way? Okay. So the process is that, I mean, so the thing is this alpha is so small. I mean, it is in S3, right? It may be some larger thing, right? So the technique is as follows. Suppose alpha is given as, I mean, consider the above example, 1, 2, 3, this, okay? Then the way of writing is alpha inverse is just uh, I mean, put the top row to bottom and keep the bottom row to the top. That is 1, 2, 3, 2, 3, 1. This is the alpha inverse, okay? This is the technique of getting alpha inverse from alpha, okay? This is the technique, okay? That's it. So in this way, we can do the calculate the inverse easily. Actually, that's the point. Okay. Now the next thing comes is that, so in group we got to know how to find the inverses and how to do the composition at a glance. Okay. Now another problem in this permutation group is that how to calculate orders. So I mean, I don't know how many of you know what does it mean by order of an element. If there anybody if don't know what does it mean by order of element, please let me know. So sorry, Tejasri, yeah. How do you, so can you please unmute yourself and I could not understand actually what does it mean, how do you write this an explanation? Can you please?
Yes, sir. How do you write that this is alpha inverse? Like we,
Oh yes,
how do
yes,
you write it as an
yes,
explanation?
yes. The thing is that it's a technique, okay? I mean, technique essentially the same thing, but it is, we are doing this just one line. Suppose alpha is given like this, okay? And in order to calculate alpha inverse, you only need to flip alpha, okay? That is, you need to put the top row to bottom and you need to put the bottom row to the top. And this will be your alpha inverse. That's it. I mean, that's the only technique. This is the only trick. That's it. I
Okay,
mean,
and
not
then
only not only this alpha. I mean, it may be some 1, 2. I mean, 4, 5, 6. Suppose it's given as S6. Okay. Then also you can flip the rows and you will what the thing you will get will nothing but alpha inverse. That's the process. Understand?
yes, and then you have composition of the two to get identity.
Yes, yes, yes. Right. So how many of you don't know about what does it mean by order of an element? Or how many of you have not heard about the term order of an element? Fine. Yeah, okay. So I am assuming that everybody knows what does it mean by order of an element. Okay. So the problem is that, I mean, suppose it is alpha is an element of H. Okay, so um, so there is one fact I once. So there is a fact. Okay, first let me write it down. Okay, so let G be a group, G be a group with n elements. Okay, and let X belongs to G. Then order of X divides n. So does everybody know this theorem? It comes under the, it's a corollary of the Lagrange's theorem, I can remember possibly. Or maybe you have seen something like that, x to the power n is equal to identity. So in any of this form, I mean, do you know this? Or anybody who has heard this theorem before?
Yes, sir.
Okay, and what about others?
Yes, sir.
No. Okay, since some of you don't know the theorem, okay, so I'm not going to using this fact. Okay, I'm not using this fact. Okay, because some of you are not familiar with this. Okay, so no issue. So okay, so let's continue with the, sorry. So let's continue with the order. Okay. So one second. Order. Okay. So suppose, I mean, so we need to understand by solving, by doing some calculations. Okay. So for example, take alpha is equal to, alpha is an element of S3, and take alpha is equal to 1, 2, 3. I mean, and 1 goes to 2, 2 goes to 3, 3 goes to 1. Okay. Okay. So okay. So yeah. So before going into order, okay, so before starting the order, we need to come up with something known as cycle representation. So how to do this? Okay, so take this alpha, 1 goes to 2 goes to 3 goes to 1. Okay, so cycle representation can be, I mean, uh, so I mean, okay, so firstly, suppose alpha, suppose beta is an element in S3, and suppose beta is written like this, and it is known that it is an element of S that is given. From this, I mean, it is a it is another type of representation instead of longhand representation of beta. Okay, so suppose beta is written as 1 comma 2 and 1 to first bracket, and it is known that it's an element of S3. So this short representation means, this means in beta 1 goes to 2. It is in first bracket 1 to means 1 goes to 2, okay, and 2 goes to 1, okay. So I mean, for some more examples, like suppose gamma is equal to 1. Oh, sorry, another thing. And observe that in this representation of beta there is no 3, but it is element of S3. Whenever this type of situation comes, this means that the element which is omitted in that representation actually that element goes to itself, that is 3 goes to 3. That is in longer hand we can write as 1 2 3 2 1 3, okay. That is the process. For example, suppose we have gamma is equal to 1 uh, 2 3 uh, 5 7. It is an element of S7, okay. So how this element gamma actually, so in reality gamma looks like 1 goes to 2, okay, then 2 goes to where 3, okay, and then 3 goes to where 1, okay. Now observe in this representation of gamma there is the number 4 is omitted, so 4 goes to 4, and then what about 5? 5 goes to 7, and then in this representation 6 is not there, so 6 goes to 6, and then 7 goes to 5, okay. So this is the this is the gamma, and in short we write it like this, okay. So I mean, it's not difficult, but the thing is, you need to convince yourself actually. I mean, the way out of writing this. Okay. So suppose delta is equal to this. So please write delta in this notion. Anybody, please write. Take your time. Okay. If you have any doubt, please ask me. Okay. Write delta in our usual notion. Okay.
Sir,
Yeah.
1 goes to 3,
Uh, okay. 1 goes to 3.
2 goes to 4,
2
3 goes to 5,
3 goes to 5, then
4 goes to 2,
okay, then
5 goes to 1.
okay, then what about 6?
6 goes
Oh,
to
sorry,
6.
6 goes to 6.
Okay, good. Okay, good. And what about others? I mean, others understand this technique properly, this process of writing properly. Please let me know if there is anyone who has issue with understanding this one notion. Please let me know. Because later we are going to use this notion only. I mean, later we're going to use this notion only. So that's why understanding this notion is very important. I shall wait for 2-3 minutes. Please take your time. If you have any issue or any doubt in this portion, please ask me, okay? Okay, Dharva to give one more example. Okay, Dharva, I'll give one more example. Okay, but before giving another example, please let's wait for 2 minutes. Let me know if any other has any confusion or doubt. Okay. Okay, it seems that it already understood it properly. Okay. Okay, so as per third requested, I'm going to give some more examples. Okay. So, so, so take alpha is equal to okay. Suppose alpha is this. Okay. So we used to write alpha in this longhand manner. Okay. So the technique is same, and it is given that it is an S9. Okay. So how do this? First, let's write all numbers from 1 to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Then look at 1 goes to 3. Then 2 goes to, sorry, 2 goes to 1. 3 goes to 4. 4 goes to 2. Okay. And in this representation, there is no 5. So 5 goes to 5. 6 goes to 9. 7 goes to 8. 8 goes to 7. And 9 goes to 6. Yeah, so yeah, that's it. So in this way you can write the long representation from the shorthand representation, namely the cycle representation. Now we also need to do the converse, that is, suppose alpha is given in this way, then we wish to write alpha as cycle representation. So what is the process? So it is given a longer way. So first write 1, because 1 goes to 2. So write 1, then 2. Okay. This 1 goes to 2. Okay. Then look at where 2 goes to. 2 goes where? 2 goes 1. So, I mean, since 2 goes 1, it is already there. And also 3 goes to 3. So we can here in the brackets. So, I mean, let me write it. Let me explain it again. So first look at 1. And then look at where 1 goes. 1 goes to 2. But then observe that 2 goes to 1. So we can end the bracket here. and the next we should start from 3, but the thing is 3 goes to itself though, so we can omit this thing, that is only 1 comma 2. Okay, but if alpha is given as, sorry, but if alpha beta is given as 1 to, sorry, sorry, beta is given as 1 to 3, then what is the scientific representation of beta? It will be as follows. Look at 1 goes to 2, okay, 1 goes to 2, and 2 goes to 3, okay, but 3, but I mean 2 goes to 3, yeah, but 3 goes to what? 3 goes to 1, but in this representation, 1, I mean, in this representation, 1 is extreme left, so end the bracket here, okay. So that is the process of writing the cycle representation. So write down sub presence. For example, suppose alpha is equal to this. Then write alpha in this cycle representation. Take your time, no issue.
Sir, 1324.
Um, 1, uh, correct. 1 to 3 already, correct, correct. What about others? Others understand this portion, this way properly, this example. Does everyone understand this example properly? Let me know.
Yes, sir. It's clear.
Okay, okay. So, but okay. So, um, so consider the following example. Suppose alpha is given as this. Then write alpha in this way.
So first bracket এর মধ্যে 1 2 3 4, second bracket is 6 7.
Um,
Hello.
yes, yes. 1, 2, 3, 4. And second
The
bracket
second
is,
bracket is 6 7.
yes, right, correct. Right. So the point is he told correctly that when you reach 4, 4 goes to 1. So this first bracket ends, and so we have to start second bracket. But then in observe that 5 goes to 5, so we can omit it, and then observe that 6 goes to 7 and 7 goes to 6. That's why he has put 6 comma 7. Okay, so that is the way. Okay, so yeah, so this all, so that's all about cycle representation. Okay, also one more, one there is one thing, I mean it's just a manipulative thing. I mean, so in cyclic representation, suppose alpha is, I mean, to say 1 2 3 is nothing but 2 3 1, right? If anyone is getting confusion, please write it down explicitly and convince yourself that it is obviously, it's obvious actually. Please take your time and convince yourself, and please let me know if you have any issue.
ঠিক আছে, yes.
Right. What about others?
Yes, sir.
Okay. So basically in cyclic representation, uh, we can start after certain 2 or 3 4 terms. Okay, then also it will be fine. That's all. Okay, so now come to the order business. So how to find order? Okay, so before going to this, okay, yeah, before going into this, we need to do the composition in terms of cycle representation. For example, suppose one second, let me examples here. Suppose alpha is equal to 1, 2, 4, and suppose beta equal to 2, 3, 5. Then what will be alpha composed beta? I mean alpha composed beta, usually we write it like this 1, 2, 4. Sorry, this is 1 second. Yeah, 2, 3, 5. What is the composition? But what this will be what? I mean write this in cycle representation. Okay. So okay, so yeah, this first is sorry. Okay, so the way is as follows. Since beta is in the last position, so you need to start with beta. Okay, so look at beta. So first 2 is here. Okay,
Excuse me, sir.
yes, yes,
Sir, when you write alpha compose beta, then just now you had said first we write beta and then alpha.
yes, yes. I mean alpha compose beta means what? First beta comes, then alpha comes, right?
Sir, here beta is 235.
Yes, right. 2 3, right. And alpha is 1 3 4, 1 2 4, right?
Means first we need to write 235 and then 124.
No, no. The point is that suppose one second. Why is my pen? Just 1 second.
So that is 1 goes to 2, 2 goes to 3, 3 goes to 5, 4 goes to 1, and 5 goes to 4.
No, no, no. You need to start with beta. Then so you need to start with 2. Okay, 2 goes to 3. Okay, and 3 goes to what? 3 goes to 5. No, no. 1 second. No, no. Sorry, it's my mistake. The way is as follows. So you need to start with 2. Okay, so 2 goes to 3. Now come to the alpha part where 3 goes to where? In alpha part 3 goes to
Yes.
3. So end here. Okay. Now again 5 is there. Okay. So in in portion beta where 3 goes to where? 3 goes to 5. So start with 5, and then in the alpha portion 5 goes to where? 5 goes to itself. So just I mean there is no point of putting 5. So it just vanish. Okay. So yeah, in this way you can write alpha. Sorry, it is the way of writing alpha composite. No, one second. One second. Okay, sorry, it's my mistake. I'm extremely sorry for that. I was also getting confused sometimes. Okay, so process as follows. Suppose alpha. So consider the previous example actually. Alpha is given as 1, 2, 4 compose. Sorry, this is alpha compose beta. Okay, 2, 3, 5. Okay. So then what will be alpha compose beta? So observe that in alpha compose beta, where 1 goes, in the part of beta, 1 goes to 1 through beta, and in part of alpha, 1 goes to 2, right? Similarly, where 2 goes to 3 in part of beta, and then in part of alpha, 3 goes to 3. Where 3 goes, in part of beta, 3 goes to 5, and then in part of alpha, 5 goes to 5. Where 4 goes, 4 goes to 4, and in part of alpha, 4 goes to 1. Similarly, in part of beta, 5 goes to 2, and in part of alpha, 5 goes to 4. So this is what? This is 1, 2, 3, 5, and then yeah, sorry. So it will be what? 1 goes to 2, 1, 2, then 3, then 5, then 4, then 1. Okay. So the way of writing it directly is that start with 1. Okay. Where 1 goes, in the right portion, 1 goes to itself, and in left portion, 1 goes to 2. 1 goes to 2. Now come to the right portion. In the right portion, where 2 goes to 3, and in left portion, where 3 goes to itself. Okay, so basically 2 goes to 3. Now again come to the left right portion, where 3 goes to 5, and in alpha, 5 goes to itself. So it's 5. Okay. Now in beta, 5 goes to 2, and in alpha, 2 goes to 4. So 5 goes to 4, and in beta, 4 goes to itself, and in alpha, 4 goes to 1. So here also we don't need to write this, we can end the bracket here. Okay, so in this way you can write alpha compose beta. Okay, so I think it's better to give some some examples actually. So suppose alpha is 2, 3, 4, and suppose beta is 1, 2. Okay, so what will be alpha compose beta? The process is as follows. Start with 1 and then look at beta, because beta is the second portion. In the beta, 1 goes to 2, and in alpha, 2 goes to 3. So in composition, 1 goes to 3. Now again look at beta, and in beta, 3 goes to 3, but in alpha, 3 goes to 4. Now in beta, 4 goes to 4, and in alpha, 4 goes to 2. In beta, 2 goes to 1, and in alpha, 1 goes to 1. So we end the bracket here. Okay, so this is the technique of doing the composition in one shot. Okay, so any confusion or doubt in this technique or in this process of these calculations, please let me know. Yes, Tanmay, you said right, sorry. Yeah, right, you said right. Anybody in confusion in understanding these techniques, I mean this processes, because this is the because this way of writing, this way of cycle representation, we are going to use it in later. Okay, so that's why understanding and dealing with this cycle representation is very important. I mean, you need to make yourself easy in this cycle representation things. Okay, so yeah, please let me know if you continue on topic. I shall wait for 2-3 minutes. Please take your time and let me know. Okay. So as the stated, so let's go with one more example. Okay. Oh, so so calculate this. So so suppose this type of question is given, how to do this, and suppose it is known that, I mean, since maximum number is 5 here, so we are in S5 already. Okay, so how to write it down? So start with 1. So first start with 1. Okay, now observe that in the right side 1 goes to 1 itself, in the middle side 1 goes to 1 itself, in the left side also 1 goes to 1 itself. So in the composition 1 goes to 1 itself, so we don't need to write 1. So we start with 2. In the right side 2 goes to 4, in the middle 4 goes to 4, and in the left 4 goes to 4. So we no need to write 2. Now start with 3. In the right, 3 goes to 3. In the middle, 3 goes to 2. And in the left, 2 goes to 5. Okay, so that's why 3 goes to 5. Now, in the right, 5 goes to itself. In the middle, 5 goes to itself. In the left, 5 goes to 2. So that's why 2 here. Okay. Now, uh, now in the right, 2 goes to 4. In the middle, 2 goes to, in the middle, 4 goes to 4. And in the left, 4 goes to 4. So, goes to 4 here. Okay. Now, in the right, in the left, sorry, in the right, 4 goes to 2. In the middle, 2 goes to 3. And in the left, 3 goes to 3 itself. So 4 goes to 3, but 3 is already in the extreme left, so we don't need to write 3 and stop here. So so this is the way. See, always you need to start from the right and slow, and accordingly you need to come to left. Okay, so that is the only process of calculating this compositions. Okay. Okay, so Lavanya, yeah, you understand the example? Okay. What about others? Is there any confusion or doubt in this process? Please let me know. Okay, so I think that everybody is fine with this. Okay? If you have any issue, please let me know. Okay. So now coming to the main thing, the calculating the order. So there is a theorem which says something like that. So oh, okay. So before starting the order, so there is one terminology comes. Okay. So the terminology is known as the N cycle. Means whose cycle representation is of the form A1, A2, dot dot AN. This type of thing is called the N cycle. This type of cycle is called N cycle. And there is one more term, transposition. Transposition means any two cycle. That is A, comma B is known as the transposition. Okay. And yeah. Okay. Now the theorem is that alpha belongs to Sn, then order of alpha is k if and only alpha is a k cycle. Okay, this is the theorem related to order, and it's a if and only theorem. That is, alpha is an element of order k, then the cyclic representation of alpha will be a k cycle. Okay. So, for example, consider alpha to be this 1, 2. Means what? 1 goes to 2, 2 goes to 1, 3 goes to 3. Now, calculate alpha square. That is alpha compose alpha. So what will be this? Check that 1 goes to 2, 2 goes to 1, 1 goes to 1, 2 goes to 1, 1 goes to 2, 3 goes to 3, 3 goes to 3. So this is identity, okay? So look at that alpha is a 1, 2, it's a 2 cycle that transposition. So if I do the square, then I get the identity. So I mean, so this is the fact, and this is the original theorem that any element is an or if it is of order k, if and only it's a k cycle, okay? And yeah, so this is one thing related to cycles. So for example, so suppose alpha is given as this. For suppose alpha is given as okay. So then if someone asks you to calculate the order, then first you need to write alpha in a cycle representation, and then you only can tell the order of the alpha, okay? Can anyone please tell what is the order of this alpha? Anybody? First put alpha in a cycle representation. Anybody please? First put alpha in cycle representation, then you can only say its order, okay? Let's solve it. Okay, so it seems that there is a confusion going on. So previously we have calculated this thing as this 3524, right? So its cycle representation will be 3524. So what will be order of alpha? Order of alpha is 4. Understood? Understand? Any confusion?
Excuse me, sir.
Yes, yes, please do.
Will you explain about this 3524 again?
Sorry to make, can you please repeat?
So how you get this 3524 within the bracket? Will you tell again, sir?
Yes,
Please.
yes, sure. Okay, so yeah, so the process is as follows. While doing the composition, first you need to start with 1. Okay, so in this portion, 1 goes to where? 1 goes to 1. In the middle portion, 1 goes to 1. In the left portion also 1 goes to 1. So in the composition, 1 ultimately goes to 1. So we're omitting 1. Okay. So now comes to 2. In the right portion, 2 goes to 4. In the middle portion, 4 goes to 4. In the left portion also, 4 goes to 4. Thanks for noting this. Actually, there is some I have done some calculation error here. Actually, okay. So yeah. So now start with 2. 2 goes to 4. In middle, 4 goes to 4. In the left portion also, 4 goes to 4. So ultimately 2 goes to 4. Okay. Now what about 4? In the right, 4 goes to 2. In the middle, 2 goes to 3. In the left, 3 goes to 3. So 3, so 4 goes to 3 ultimately. Now in the right, 3 goes to 3. In the middle, 3 goes to 2. In the left, 2 goes to 5. So ultimately in the composition, 3 goes to 5. Now in the right, 4 goes 5 goes to 5. In the middle, 5 goes to 5. In the left, 5 goes to 2. So 5 goes to 2. But 2 is already written in the first, so we are ending the bracket here. Okay. So in this way we can write this thing. You understand?
Yes, sir.
Okay. And that's why since it is a fourth cycle, so its order is alpha. Okay. So this is the way process. Understand? So now observe one thing, that this theorem is given only for alpha is the case cycle. But then what about any cycles of the form this? This type of thing is not covered in this cycle, right? So for this, there is some theorem. So let me stretch it once again. Okay, so before doing this, we need to introduce one term by disjoint cycle. So can anybody please tell what does it mean by disjoint cycle? Can anybody please tell what does it mean by disjoint cycle?
Means there are no any elements common between the two cycles.
So suppose alpha belongs to Sn and let alpha is a composition, sorry, alpha is an composition of this of these are disjoint cycles. Okay. And suppose order of alpha sigma I is equal to gen I. Then this theorem, then the theorem tells that order of sigma is nothing but LCM of order of sigma 1, order of sigma 2, order of sigma k. Okay, this is the theorem. So this theorem tells that if alpha can be written as disjoint cycle, then its order will be LCM of this. Okay, LCM of this. Okay. Now, so now, okay. Okay, so before going into some next theorems or something, first let's solve some problems. Okay. So take alpha is equal to 1, 2, 2, 1, 3, 4, 4, 5, 5, 6, 6 is equal to 1, 3, 3, 2, 2, 3, 5, 6, 6, right? And gamma is equal to 1, 4, 2, 3, 3, 2, 5, 4, 5, 5, 1, 6, 6. Now the question is, find the followings. Uh, Alpha, beta, gamma inverse, gamma alpha, gamma inverse. Okay. Yeah. Solve this problem. Take your time. Solve this problem. Okay. I shall back after 2-3 minutes. Okay. You solve this problem. You can take your time. So, so can anybody please tell the answer? Okay, so Mr. Rangeshwaran.
Sir, first two is solve. Alpha beta equal to first bracket 142 and 53,
Okay,
and gamma inverse is one first bracket 154 and second bracket 32.
okay. So calculate the gamma from alpha gamma inverse. Yes, the alpha composite beta and gamma inverse you calculated correctly. What about the others? Anybody solving? Anybody getting any difficulties in calculating this? Please let me know. What about others? Please let me know. Any difficulty others are facing?
No, sir. 1 and 2 have been solved.
Okay, one you have solved. Okay, so okay, then calculate the third one.
The third one is remaining, sir.
Yes, yes, do it.
And sir, last three is first bracket, sir,
Yes, yes, yes.
first bracket 1625 and
Okay,
second bracket 34.
yeah, right, correct. Right. And what about others? Is there any issue in the calculation?
Excuse me, sir.
Yes, yes.
So excuse me, sir.
Yes, yes, please tell.
So in this third number, if you write 3 4 first and then we write 165, will it be wrong?
It is also fine because I mean because they are disjoint, right? So it is also correct.
Okay, sir.
Yeah. Okay. So there is one small concept is there known as uh, permutation and odd permutation. So what does the even permutation? An element alpha belongs to Sn called even permutation. It can be expressed as product of even number of cycles. Okay. Even permutation means product of even of two cycles, and similarly, odd permutation means product of odd number of two cycles. Okay, that's it. So, for example, uh, take beta to be, so for example, take alpha to be 1, 6, 3, 7, 2, 4, 5. So, first, whether is it even or odd permutation, just determine it. So, first write alpha as product of two cycles. First write it down as product of two cycles. Okay. Okay. The thing is, you can write product of two cycles by doing lots of calculation, but in reality there is a technique which you need to know. Okay. Suppose alpha is given like this, then how to write alpha? How to write alpha as a product of two cycles? Write as follows. First, look at the first cycle and break it down as two cycles as follows. First, write the first term, okay, and then write the last term of the first cycle. Okay. Then again write the first term of the first cycle, and then write the second last term of the first cycle. And similarly 1 6, and then similarly this disjoint, this cycle 2 5 2 4, right? So in this way we can write alpha the product of two cycles. Okay. So this is a technique. If you break this alpha you will get same thing, but the technique is of writing as a product disjoint cycle is first as follows. Consider the first cycle and consider one. Write down the first element, and then the second element will be the last element of the first cycle, that is 7. Then again 1 comes, and then 3 is in the second element, then 1 comes and 6 is the second element. Then in the second cycle, 2 is the first element and the last element of the second cycle is 5. So put 5 here and then we did 2 comma 4. So in this way you can write a cycle as product of two cycles. Okay. So this is technique. So I mean, any confusion of understanding this technique?
Excuse me, sir.
Yes, yes.
So if I write 131617, then also it's all right.
Uh, no, no,
If I change the position, then it doesn't matter.
no, it matters because if you write 131617, right?
Yes.
So in this composition, where one goes, right portion 1 goes to 7, and after all 1 goes to 7 in this composition, right? Correct? In your composition, right? 1 goes to 7. But in this portion 171316, in this composition 1 goes to where? 1 goes to 6, right? So that is why the thing is two cycles will commute if and only if they are disjoint. Okay, because there is no involvement of one in other, so you can uh, uh, change the positions. But whenever there is a non-intersection, you can't write. You can changes places. You can change places. Okay, understand? Yeah.
Yes.
So yeah, right. So in this way, you can write a product of two cycles. So consider for example. So okay. So take alpha is equal to 1 6 2 4 sorry 3 7 4 5 5 2. Then is alpha inverse in permutation. So first calculate the alpha inverse, then using the technique previously write down alpha inverse a product of disjoint cycles. Okay, so do it. Take it there.
Answer is no.
Yeah, right. You are right. It is not a proportion. What about others?
Yes, sir. It's not an even permutation.
Okay. So how you calculate it? First you have calculated alpha inverse, then you take you break it in the two cycles, right?
Yes, sir.
Okay. So alternatively, it can be done as follows. I mean, it's an alternative one. I mean, both are same, but anyone can be used. Anything. I mean, any way can be used according to confidence. Okay. So first we write alpha as a product of disjoint cycles. Suppose A, B, C, D, E, F. Then we are taking alpha inverse. Alpha inverse what? EF inverse, CD inverse, AV inverse. So this will be, I mean, EF inverse will be EF, right? So in this way, you also calculate alpha inverse. I mean, we can also write alpha inverse of probability to disjoint cycles. Okay, and whichever way is convenient, we need to use according to the situation, right? So now, so consider the following question. So calculate the order of the following. 1, 3, 4, 7, 5, 7, 1, 2, 5, 4 whole square, 1, 2, 3, 2, 5. So calculate the orders of these two elements. But what about others? I mean, others are getting any issues, any complications in calculations? Please let me know. There are total, how many is there are around, there are 11 students, yeah. Yeah, and so what about other 9 or 10 students? If you are getting any issues, any doubts, please let me know. So if you solve this question, anyone of you, please let me know the answers.
Five and nine.
Why 9? How you get 9?
First bracket is double three. 1, 2, 3, 5, 4 is order is 3. What square is double.
Then you can write it down in the disjoint cycle or write it down in the, I mean,
Uh,
product of cycle you can write it down. Okay. Or you can also explicitly, yeah, first you can also write it down explicitly, then you can write down a cycle or product of cycles. Okay. When 9 will can't be answered. If you have any doubts, any we don't ask in chat, okay? Because in the screen I could not be chat without switching the hand up there. So you should directly ask. So what are the orders? I mean, anybody? Just first write it down in the disjoint cycle. Or first write down explicitly. Then only you can calculate. But I mean, just being this.
Excuse me, sir.
Yeah.
Please help with now once I cannot break down.
So in the first problem, so this is 1, 3, 4, 5 to 4. Okay. So so um, so first compute the composition. Okay. So in the first portion, where one goes to one, I mean, in the right portion, one goes to one, and in the left portion, one goes to three. So one goes to three. In the right, three goes to three. In the left, three goes to four. Four. In the right, four goes to two. In the left, four goes. In the left, two goes to two itself. Okay. In the right, two goes to five. In the left, five goes to five. Okay. So two goes to five. In right, five goes to four. In left, four goes to seven. In right, seven goes to seven. In left, seven goes to one. But one is always the left side, but so that's why we're writing as this. So this is the whole composition, and it's a one. I mean, and it's a one, two, three, four, five. It's a six cycle, right? Six cycle, correct?
Yes. So its order will be 6. Okay.
Yes. So order will be six. I mean, so we have a theorem initially, right? Theorem, right? Yeah. Uh, disjoint. Sorry. Yeah, an element is of order k if and only if the k cycle, right? So this that can we are directly using it. Understand?
Yes.
Yes. And second, for the second problem, break it down as joint cycle. And yes, someone answered it as five. Yes, five will be the order of the for the second problem. You can break it down, and then you can see if the cycle, or you can represent joint cycle. Then only you can get the answer. Okay, understand?
So and in second number, what about this is square? We need to write 1, 2, 5, 4 two times.
Yes, right, right. Means composition. Suppose F composite means F square, right? So this is the 1, 2, 5, 4. Compose 1, 2, 5, 4. Two times composition. That's it.
Okay. Okay. Okay, sir.
Okay, so I am ending here. Okay. So if you have any issue or doubt, please ask me in the next session. Okay. Okay. So I am disconnecting this call. Okay.
Okay, sir. Thank you, sir.